The Indian Geotechnical Society, which was earlier known and founded under the name of the Indian National Society of Soil Mechanics and Foundation Engineering, was established in 1948. This came soon after the Second International Conference on Soil Mechanics and Foundation Engineering held in Rotterdam. The society was affiliated to the International Society in the same year, and since then it has strived to fulfill and promote the objectives of the International Society. The name Indian Geotechnical Society was adopted in 1970. The vision of the founding president, Mr. Khosla, and the honorary secretary, Dr. N.D. Gulati, was to build the society to promote cooperation amongst engineers and scientists for the advancement and dissemination of knowledge in the fields of soil mechanics, foundation engineering, soil dynamics, engineering geology, rock mechanics, snow and ice mechanics, and allied fields and their practical applications. As the geotechnical community started to grow, the International Society decided to have regional conferences for each continent, along with having 4 yearly international conferences. This is when the first Asian Regional Conference was held in 1960 in New Delhi. India also hosted the 5th Asian Regional Conference at Bangalore in 1975 and the 13th one at Kolkata in 2007. IGS has been organizing national conferences annually in different cities since 1961. The Silver Jubilee Conference was held at Kurukshetra in 1973. 1978's GeoCon was a landmark conference held at IIT Delhi, which was inaugurated by the then Prime Minister Morarji Desai. IGS started the prestigious annual lecture in 1978. A tradition followed till date. The first one was delivered by Professor R.K. Katti. Several others who delivered the annual lectures include Professor Dinesh Mohan, Professor T. Ramamurthy, Dr. R.K. Bhandari, Professor Gopal Ranjan, Dr. B.G. Rao, Dr. N.V. Nayak, Professor G.V. Rao, Professor A.V. Shroff, and most recently, Professor M.N. Viladkar. IGS made an impressive debut in the international scene in 1994 with the organization of the 13th International Conference on Soil Mechanics and Geotechnical Engineering that was held in New Delhi. This was one of the biggest conferences in the history of the International Society, and it firmly put India on the international map.
24 years ago, in 1994, the Indian Geotechnical Society organized the 13th International Conference on Soil Mechanics and Foundation Engineering in New Delhi. This conference was a great success. Everything went perfectly as planned. Its technical sessions, its exhibition, its field trips, its delegate interaction, its companions program, its entertainment, and hospitality. Dr. Parry, the Secretary General of the International Society, in his concluding remarks, branded the conference as a magic carpet conference.
The turning point came from the 12th Annual Regional Conference in Singapore, which saw more than 20 Indian participants and the keynote lecture by Professor Madhav. We were successful in winning the next ARC at Kolkata and also Professor Madhav as Vice Presidentship for Asia for the term 2005 to 2009.
The major visible contributions from Indian Geotechnical Society have been in the latest 21st century. A large contingent had attended the Singapore Asian Regional Conference, followed by election of Professor Iman Madhav as the next Vice President for the term 2005-2009. Several of our members have been, members of IGS have been members of the technical committee, and the most recent achievement of our society has been the keynote lecture or plenary lecture given by Professor Babu at the Seoul International Conference. with the kind of enthusiasm and activities of the Indian Geotechnical Society and its members, I look forward to a much more greater role for IGS in the international community.
The Golden Jubilee Conference was held in 1998 at Delhi. IGC has hosted the council meeting of ISSMGE at Bangalore and the 6th Asian Young Geotechnical Engineers Conference very successfully, thanks to great efforts by Professor Sitaram, Professor Srinivas Murthy and the team. IGS was successful in bidding for the 6th International Conference on Environmental Geotechniques to Delhi in 2010, which was a great success with due to Professor Manoj Datta's great efforts. The international community has become aware of our true potential, with several of our members becoming active in several technical committees of ISSMGE. IGS has a full-fledged office in New Delhi catering to the needs of its members. IGS publishes a quarterly journal since 1962. It is now accessible online to all IGS members free of cost. Since 2012, the journal is being published by Springer for qualitative improvement and international reach. It has wide circulation and is retrieved internationally. IGS also publishes a quarterly newsletter to keep its members abreast of all geotechnical events. IGS operates through its local chapters that keeps its flag high in different cities of India. With 44 active chapters, IGS has spread its reach to every part of the country. Some of the active local chapters include Delhi, Roorkee, Mumbai, Indore, Pune, Goa, Surat, Bangalore, Chennai, Kolkata, Guwahati, and several others. To encourage the chapters, an annual Best Chapter Award was instituted in 1995. The Delhi chapter has won this award a record 5 times. The geotechnical industry in India is incomplete without its partnerships with geologists, earth retention system contractors, consultants, and public sector organizations. Institutions like the IITs, CSMRS, CRRI, CBRI provide industry-academia interaction so that the benefits of research reaches the industry and the industry can input to the academia what the thrust of the research should be. This helps in directly applying the findings of the research on the ground for real implementation. With the growing demand for land, we have skyscrapers sprouting up in every big and small city in India. As industries grow, demand for power and power plants also increases. Connecting the industries through bridges, highways, railways, and metros, the Indian geotechnical landscape only shows a promising future. This also means that there is a demand for quality work as the margin for error is nil. Today, IGS is working towards setting up a joint assessment for testing soils along with the National Accreditation Board for Laboratories, the NABL, to match the quality of testing with the international standards. IGS is also working with the Bureau of Indian Standards to prepare Indian standard codes in several aspects of foundation design and field and laboratory testing. Many of our members serve in these committees.
The future is very bright and full of optimism. A number of initiatives have been taken up, promotion of student chapters in various colleges and institutes to sensitize the students about the importance of geotechnical engineering in the curriculum and the practice. Creation of number of professional groups to make them aware of the future challenges and opportunities in geotechnical engineering. A number of initiatives such as interactions with other professional groups that are overlapping with geotechnical practice are also initiated. It's hoped that with all these initiatives and further initiatives that one can have at IGS level, there could be better geotechnics in the country, which ultimately lead to better, cleaner, sustainable societies.
The future of geotechnical engineering lies in the hands of today's students. Recognizing this, IGS has set up student chapters in some cities, several more in the offing. As we celebrate the 70th year of the Indian Geotechnical Society, the possibilities that we look forward to are limitless. Here's to saluting the past, celebrating the present, and welcoming the future.
Nestled among the mighty Himalayas stands a temple of education, an institution that shapes young minds of today into ambitious, conscientious, and dauntless individuals. Individuals who will become leaders of tomorrow. This is Jaypee University of Information Technologies, Solan, where education meets excellence. Conceived as the joint vision of the Government of Himachal Pradesh and the founder chairman of Jaypee Group, Shri Jaiprakash Gaur, JUIT Solan is the first private university of Himachal Pradesh established in 2002. Over the last 2 decades, JUIT Solan has been relentlessly pursuing its mission of contributing to a better world by cultivating creativity and advancing fundamental knowledge through education among students. Adorning the picturesque slopes of Waknaghat hills in the Solan district of Himachal Pradesh, the university campus spread across 25 acres provides a peaceful and serene setting in the lap of nature for young minds to hone their skills for a brighter future. JUIT offers undergraduate, postgraduate, and doctoral programs in various fields of study to include computer science and engineering, information technology, electronics and communication engineering, biotechnology, bioinformatics, civil engineering, and management.
JUIT has been producing polished graduates who are working as experts in various fields in country and abroad. More than 200 alumni have become acclaimed professionals in countries like Canada, America, and also Europe.
As Dean Academics and Research, I have had the privilege of witnessing a remarkable journey here. We aim to provide an educational opportunity to one and all, irrespective of their background. In JUIT, our main aim is to produce industry-ready professionals and good human beings. From the beginning, our institution has been known for its research and innovation, and now it emphasizes on interdisciplinary research and collaborative work. We are also aligning with the principles of NEP 2020, and following NEP, we are preparing the students to excel in their professional journey. We have been continuously ranked in NAC and NIRF. Now we are also ranked in international rankings such as the Times Higher Education ranking and QS ranking.
We regularly upgrade the IT infrastructure at our university. Recently, we have added a good number of new machines in various labs.
With modern hostels for both boys and girls, faculty residences, a healthy and hygienic students' mess, auditorium, sports facilities, and other amenities. The university campus makes life vibrant and enjoyable for students, both inside and outside the classroom.
Handling 1900 students in the age group of 17 to 23 years is challenging. In JUIT, we create a conducive ecosystem for a student to develop and nurture his or her personality besides the academic curriculum, providing excellent amenities in the hostels, good nutritious food, active sports fields, Vibrant and diverse co-curricular activities, clubs, NCC, etc. are all domains which fall in my responsibility as the Dean of Student Welfare.
The university exposes its students to placement teams from several well-known companies, and the students here in this university do get placements in the organizations like Microsoft and Amazon.
JUIT Solan stands tall as an institution committed to academic excellence, holistic development, and industry relevance. With its focus on research and innovation, as JUIT graduates step into the professional world, they carry with them not only knowledge but also the skills, values, and perspectives necessary to make a positive impact on society.
So, hello and good morning to everyone. I welcome you all on behalf of IGS Shimla chapter and also from Civil Engineering Department, Jaypee University of Information Technology. So, very welcome to you all. There is a slight message to you. We'll be starting in like 10 to 15 minutes as there is some technical default on the behalf of the speaker. So, please bear with us and please stay at the forum. Thank you. Meanwhile, we'll be sharing some links with you. Please go through them.
Nestled among the mighty Himalayas stands a temple of education, an institution that shapes young minds of today into ambitious, conscientious, and dauntless individuals. Individuals who will become leaders of tomorrow. This is Jaypee University of Information Technology's Solan, where education meets excellence. Conceived as the joint vision of the Government of Himachal Pradesh and the founder chairman of Jaypee Group, Shri Jaiprakash Gaur, JUIT Solan is the first private university of Himachal Pradesh established in 2002. Over the last 2 decades, JUIT Solan has been relentlessly pursuing its mission of contributing to a better world by cultivating creativity and advancing fundamental knowledge through education among students. Adorning the picturesque slopes of Waknaghat hills in the Solan district of Himachal Pradesh, the university campus spread across 25 acres provides a peaceful and serene setting in the lap of nature for young minds to hone their skills for a brighter future. JUIT offers undergraduate, postgraduate, and doctoral programs in various fields of study to include computer science and engineering, information technology, electronics and communication engineering, biotechnology, bioinformatics, civil engineering, and management.
JUIT has been producing polished graduates who are working as experts in various fields in country and abroad. More than 200 alumni have become acclaimed professionals in countries like Canada, America, and also Europe.
As Dean Academics and Research, I have had the privilege of witnessing a remarkable journey here. We aim to provide an educational opportunity to one and all, irrespective of their background. In JUIT, our main aim is to produce industry-ready professionals and good human beings. From the beginning, our institution has been known for its research and innovation, and now it emphasizes on interdisciplinary research and collaborative work. We are also aligning with the principles of NEP 2020, and following NEP, we are preparing the students to excel in their professional journey. We have been continuously ranked in NAC and NIRF. Now we are also ranked in international rankings such as the Times Higher Education ranking and QS ranking.
We regularly upgrade the IT infrastructure at our university. Recently, we have added a good number of new machines in various labs.
With modern hostels for both boys and girls, faculty residences, a healthy and hygienic students' mess, auditorium, sports facilities, and other amenities. The university campus makes life vibrant and enjoyable for students, both inside and outside the classroom.
Handling 1900 students in the age group of 17 to 23 years is challenging. In JUIT, we create a conducive ecosystem for a student to develop and nurture his or her personality besides the academic curriculum. Providing excellent amenities in the hostels, good nutritious food, active sports fields, vibrant and diverse co-curricular activities, clubs, NCC, etc. are all domains which fall in my responsibility as the Dean of Student Welfare.
The university exposes its students to placement teams from several well-known companies, and the students here in this university to get placements in the organizations like Microsoft and Amazon.
JUIT Solan stands tall as an institution committed to academic excellence, holistic development, and industry relevance. With its focus on research and innovation, as JUIT graduates step into the professional world, they carry with them not only knowledge but also the skills, values, and perspectives necessary to make a positive impact on society.
The Indian Geotechnical Society, which was earlier known and founded under the name of the Indian National Society of Soil Mechanics and Foundation Engineering, was established in 1948. This came soon after the Second International Conference on Soil Mechanics and Foundation Engineering held in Rotterdam. The society was affiliated to the International Society in the same year, and since then it has strived to fulfill and promote the objectives of the International Society. The name Indian Geotechnical Society was adopted in 1970. The vision of the founding president, Mr. Khosla, and the honorary secretary, Dr. N.D. Gulati, was to build the society to promote cooperation amongst engineers and scientists for the advancement and dissemination of knowledge in the fields of soil mechanics, foundation engineering, soil dynamics, engineering geology, rock mechanics, snow and ice mechanics, and allied fields and their practical applications. As the geotechnical community started to grow, the International Society decided to have regional conferences for each continent, along with having 4 yearly international conferences. This is when the first Asian Regional Conference was held in 1960 in New Delhi. India also hosted the 5th Asian Regional Conference at Bangalore in 1975 and the 13th one at Kolkata in 2007. IGS has been organizing national conferences annually in different cities since 1961. The Silver Jubilee Conference was held at Kurukshetra in 1973. 1978's GeoCon was a landmark conference held at IIT Delhi, which was inaugurated by the then Prime Minister Morarji Desai. IGS started the prestigious annual lecture in 1978. A tradition followed till date. The first one was delivered by Professor R.K. Katti. Several others who delivered the annual lectures include Professor Dinesh Mohan, Professor T. Ramamurthy, Dr. R.K. Bhandari, Professor Gopal Ranjan, Dr. B.G. Rao, Dr. N.V. Nayak, Professor G.V. Rao, Professor A.V. Shroff, and most recently, Professor M.N. Viladkar. IGS made an impressive debut in the international scene in 1994 with the organization of the 13th International Conference on Soil Mechanics and Geotechnical Engineering that was held in New Delhi. This was one of the biggest conferences in the history of the international society, and it firmly put India on the international map.
24 years ago, in 1994, the Indian Geotechnical Society organized the 13th International Conference on Soil Mechanics and Foundation Engineering in New Delhi. This conference was a great success. Everything went perfectly as planned. Its technical sessions, its exhibition, its field trips, its delegate interaction, its companions program, its entertainment, and hospitality. Dr. Parry, the Secretary General of the International Society, in his concluding remarks, branded the conference as the Magic Carpet Conference.
The turning point came from the 12th Annual Regional Conference in Singapore, which saw more than 20 Indian participants and the keynote lecture by Professor Madhav. We were successful in winning the next ARC at Kolkata and also Professor Madhav as Vice Presidentship for Asia for the term 2005 to 2009.
The major visible contributions from Indian Geotechnical Society have been in the latest 21st century. A large contingent had attended the Singapore Asian Regional Conference, followed by election of Professor Iman Madhav as the next Vice President for the term 2005-2009. Several of our members have been, members of IGS have been members of the technical committee, and the most recent achievement of our society has been the keynote lecture or plenary lecture given by Professor Babu at the Seoul International Conference. With the kind of enthusiasm and activities of the Indian Geotechnical Society and its members, I look forward to a much more greater role for IGS in the international community.
The Golden Jubilee Conference was held in 1998 at Delhi. IGC has hosted the council meeting of ISSMGE at Bangalore and the 6th Asian Young Geotechnical Engineers Conference very successfully, thanks to great efforts by Professor Sitaram, Professor Srinivas Murthy and the team. IGS was successful in bidding for the 6th International Conference on Environmental Geotechniques to Delhi in 2010, which was a great success with due to Professor Manoj Datta's great efforts. The international community has become aware of our true potential, with several of our members becoming active in several technical committees of ISSMGE. IGS has a full-fledged office in New Delhi, catering to the needs of its members. IGS publishes a quarterly journal since 1962. It is now accessible online to all IGS members free of cost. Since 2012, the journal is being published by Springer for qualitative improvement and international reach. It has wide circulation and is retrieved internationally. IGS also publishes a quarterly newsletter to keep its members abreast of all geotechnical events. IGS operates through its local chapters that keeps its flag high in different cities of India. With 44 active chapters, IGS has spread its reach to every part of the country. Some of the active local chapters include Delhi, Roorkee, Mumbai, Indore, Pune, Goa, Surat, Bangalore, Chennai, Kolkata, Guwahati, and several others. To encourage the chapters, an annual Best Chapter Award was instituted in 1995. The Delhi chapter has won this award a record 5 times. The geotechnical industry in India is incomplete without its partnerships with geologists, earth retention system contractors, consultants, and public sector organizations. Institutions like the IITs, CSMRS, CRRI, CBRI provide industry-academia interaction so that the benefits of research reaches the industry and the industry can input to the academia what the thrust of the research should be. This helps in directly applying the findings of the research on the ground for real implementation. With the growing demand for land, we have skyscrapers sprouting up in every big and small city in India. As industries grow, demand for power and power plants also increases. Connecting the industries through bridges, highways, railways, and metros, the Indian geotechnical landscape only shows a promising future. This also means that there is a demand for quality work as the margin for error is nil. Today, IGS is working towards setting up a joint assessment for testing soils along with the National Accreditation Board for Laboratories, the NABL, to match the quality of testing with the international standards. IGS is also working with the Bureau of Indian Standards to prepare Indian standard codes in several aspects of foundation design and field and laboratory testing. Many of our members serve in these committees.
The future is very bright and full of optimism. A number of initiatives have been taken up, promotion of student chapters in various colleges and institutes to sensitize the students about the importance of geotechnical engineering in their curriculum and the practice. Creation of number of professional groups to
hello, Mr. Rajesh.
make them aware of the future challenge.
So, good morning to everyone on behalf of IGS Shimla chapter. And now we have our guest and a speaker of the day with us, Dr. Neelima Satyam. So, good morning, ma'am, and welcome to IGS Shimla chapter.
Yeah, good morning, good morning. I'm sorry I got stuck in the traffic. So.
No problem, ma'am. It can happen sometime. Shall we start with the introduction part now?
Please.
Okay, so good morning. So before we start today's proceeding, let me give a little introduction about the speaker. So our speaker for the day, Dr. Neelima Satyam, is currently professor in the Department of Civil Engineering at IIT Indore and a very active member of the IGS. She holds a PhD and MTech from IIT Delhi and a BTech from SB University, Tirupati. Before joining IIT Indore, she also served as an assistant professor at Earthquake Engineering Research Center at IIT Hyderabad. Dr. Satyam was also a visiting researcher at Kyushu University, the University of Stuttgart, and the University of Tokyo, and she is actively involved in teaching research and consultancy in geotechnical engineering. Her expertise lies in geotechnical earthquake engineering, microzonation, site response studies, landslide hazard monitoring, microseismic data processing, and rock engineering. She has published more than 150 papers in international and national journals and conferences. Her research publications have received Best Paper Awards from IGS, AGU, and IIT Indore. Dr. Satyam has also received research grants from DST, MHRD, AICTE, IITRA, DAE, NIOT, NRDMS, ISRO, and MOES. She is a recipient of IEI Young Engineers Award, BRNS Young Scientist Research Award, AICTE Career Award, JSPS Fellowship, Young Woman Engineer Award from INWES, CIDC Vishwakarma Award, ISCT Samsher Prakash Mid-Career Research Award, SERB Power Fellowship, IGS Sardar Resham Singh Memorial Award, Best Woman Researcher in Geotechnical Engineering Award, and many more. She has been among best editorial members and reviewers of Indian Geotechnical Journal, which is now a top journal in geotechnical engineering, has received Best Paper Awards for deep foundation and retaining structures from IGS. She has also received OSP award for her work on forecasting landslide in Darjeeling Himalayas by American Geophysical Union. Additionally, she had been co-opted member of PEC Civil and Mechanical Engineering SERB DST. She has been the chairperson of the selection committee for MEXC scholarship in Japan, and she's a fellow of JSPS, IGS, ISCT, and IAI. And she's also presently the editorial board member of several reputed journals, including Nature Scientific Reports and Journal of Rock Mechanics and Geotechnical Engineering. So much more to tell about her. I've just shortened the introduction because she's very active in geotechnical engineering. Many more works have been done by her and are to be done by her, especially in Himalayan region. So with this, I'll hand over the stage to Dr. Neelima to please present her lecture.
So, good morning, everyone, and thank you so much, Neeraj. And I'm so happy to give this talk under IITR Shimla chapter panel because the chapter is again being started active. So, congratulations for all the efforts to bring it to active. I congratulate the entire team of your institute and your other colleagues to organizing this particular event. So, with this very brief introduction, I extend my apology for being late. So, I'll try to present my presentation. Could you see my presentation?
Yes, ma'am.
Is it?
Yes, it is visible.
Okay, so my topic will be on combined landslide hazard in Western Himalayas. So this project has been funded from DST, and sometime in 2001 or 2020 end. So the study area is in some part of Uttarakhand that has been given by the sponsor, and we selected Joshimath in 2021, early 2021. So what I'm going to try to bring here is like the landslides are such a big, hazard or the very serious geo hazard to be considered, especially in Himalayan region and also in the Western Ghats and Eastern Ghats, which may be either because of rainfall or maybe because of earthquake. But the combined effect, especially for seismic landslides, along with the rainfall, has not been studied. At least in the country, no studies have been done on the combined landslide hazards. So that's why this particular piece of work, I feel like it's very crucial to present. So my today's topic content goes like this. I'd like to give the brief introduction why this combined hazard we need to carry. Actually, it is not just earthquakes and rainfall. It is also snowfall in the area where we selected. So that means like in the monsoon you have rainfall, and then you have a snowfall, and pore pressures have been there. And once, like, even if a micro seismic activity happens, because Himalayas are such an active seismically, so even a small earthquake of 2.5 or 3 occurs, there may be possibility of a huge failure. And so how we have done that? So this is a flow of the work that we have done. So final output should be like the overall outcome that Government of India want was like to develop an operational early warning system. So we really don't have warning systems in the place, okay, so in the country. So we are trying to develop this. Of course, we did this. The project is just completed. So we developed this both at the regional scale and the local scale, and the two dynamic early warning system. That means like it changes with time, including the dynamic landslide susceptibility. So I will be briefing you what we have done, especially for susceptibility mapping. And to start the project, what we have done is like, because the sponsors was also not clear like which study area, they just want me to take some part of Uttarakhand. So then like we started looking at like, susceptibility mapping for Chamoli district, which is more vulnerable because based upon the inventory data we collected. And then we we have adopted this top-down approach, and then we also done the rainfall thresholds for this particular district. And then the third one is like soil thickness map of the Joshimath and the surrounding regions were being developed. Then we incorporated Monte Carlo simulations in the TRI-GRS model for the LSM. And then finally, we tried to do the warning system by doing the real-time monitoring as well. So we have our real-time monitoring site, which has been in Joshimath, near Joshimath, 20 kilometers from the Joshimath town, which is in a village called Lambagat village, which is very, very serious. There was a Lambagat landslides in the past also. So we have our slope monitoring complete system has been instrumented and the data every 10 minutes. So if you see that the global database, so several earthquakes or landslides happened, especially 75% of these events are concentrated in the Asian terrain. And look at the global database also, the seismic landslides especially, so 54% in this, 75% are basically, because of these seismic activity. And India being a major triggering factors, especially for in the Himalayan region or both rainfall and earthquake. If you look at the Western Ghats, we don't have seismic activity. Basically, they are induced of rainfall induced. But even Eastern Ghats also. So, but Himalayas are such a fragile formations and highly seismic. And because of whatever climate region factors, etc., that even the flood events are very, very. And then if you look at the Uttarakhand, state of Uttarakhand, which is the part of Western Himalayas, and this is the most seismically active region, we know that earthquake-induced landslides are very, very common in this particular state because of the fractured geology and tectonic framework. And if you see the figure 2, there are a lot of number of landslides that are caused from several earthquakes which are in the central Himalayan gap as well. So between the two major, like we had 1905 Kangra earthquake and 1934 Nepal India earthquake. So it is also known that this central Himalayan gap has very obviously seismologists have claimed that there may be possibility of a major great earthquake in future. And Uttarakhand has the highest vulnerability among all the Himalayan states, especially with respect to the landslide susceptibility mapping of the country. And due to this high seismicity, it is also selected for the co-seismic landslide hazard zones. So we started every time, like whenever we had any project on this, like we go to the site, right? So we also made several site which is across the state, and over 1100 landslide incidents were reported only in 2023 from the state of Uttarakhand. And every year, several small to major landslides are reported in Joshimath region in this particular state, and this has been like because of having 50 active landslide zones. In 2023, the total 309 landslides were caused, like they were either complete or partial road blockages. It's a very major issue, especially during the monsoon. And these road blockages were identified along these 247 kilometer stretch between Rishikesh and the Joshimath. So in the recent past, I've seen a lot of subsidence news about the Joshimath town sinking down, right? So let me tell you, it is not just only the Joshimath which is having this kind of subsidence problems. At least like 200 such towns are there in the Himalayan region. Only Joshimath came into the news because of whatever reasons, but the land or ground subsidence is very, very common in the Himalayan regions because of the drainage issues, which I'll be talking later in my slides. This has been the major problem identified in, like, not just today's problem because some hydropower plant has been come up or something. It has been like a progressive sort of phenomena happening for several decades, and this is persistent, and because of whatever ongoing nature of the concern. So several reports have been published in the last 1 year as well on this particular Joshimath subsidence issues. So some of the photographs during our visit as well, Joshimath and the surrounding area lie in the main Himalayan, thrust faults, and then this town is situated over a very thick deposit of collivium, because there may be past old landslide deposits on which is highly unconsolidated, and the town has been built on such debris. So that's why this kind of subsidence phenomena has been observed. So the primary cause of this is basically internal erosion. Okay, because as I said, like it's a drainage issue, so subsurface drainage issue, and the possible sources of infiltration of rainwater, melting ice, and sometimes wastewater discharge also, because this is a small town. So people, when there is a small streamlet coming, which is a natural streamlet, people are blocking that streamlet, and then water is very smart and it takes its own course and coming out somewhere again. So these are all some of the observations we could make it. Then we started looking at Chamoli district in the Uttarakhand, because Uttarakhand state itself is such a large area. So what we want is to develop the regional early warning system. So we looked at the susceptible map, which was very important. And also what we did is we also applied some machine learning based LSM models have been done for this particular district using 13 causative factors such as TWI, PGA, SPI, geomorphology, geology, slope, elevation, aspects, and the other factors. So initially we prepared this landslide inventory using various sources, such as we started with the Google Earth, site visits, satellite images. A huge amount of data has been collected. And the prepared inventory, we had 363 landslide points, and many of these are get reactivating every year. This was the observation because we have been looking at this for the last 3 years. And the duration, what we considered was from 2000 to 2023, and we considered all the 4 conditioning factors for landslide susceptibility, which included whatever the parameters I said, including rainfall, PGA, etc. So these are the geospatial layers of each causative factors, which is having a resolution of 12.5 meters. And then you see this one, these are the conditioning factors, which I said, 11 conditioning factors. And this figure, it shows a correlation between various causative factors, where we can observe highest negative correlation is observed between the slope and TWI. And the highest correlation coefficient is between elevation and the distance from the road. So this shows, and we developed a methodology where we performed LSM using 5 different machine learning algorithms, and because every time you have to forecast also. To develop a warning system, you need to have a proper forecasting model. So for that, what we've done is 5 machine learning algorithm has been adopted. In this, 80% data we used it for training and 20% for testing. And model evaluation was done using parameters such as AUC, accuracy, position, recall, and F1 score. So this is the performance on non-classified data. In this study, initially, what we did is we try to compare different ML models with non-classified data of the causative factors. RF was found to be most accurate. There is random forest method model in case of non-classified data. And the results of the K-fold cross-validation was also showed the best accuracy, especially in case of RF model. So we use this one to compare our input database in case of classified data also. So these are the LSM maps from different machine learning algorithms. You can see here we applied names base, logistic regression, KNN, SVM support vector mission, etc. Then LSM that's obtained from RF model, which because it's giving good accuracy, it's classified taking random and NLSM reference for non-landslide points also, as you see in these 2 figures. So we try to see what is that distribution, pixel distribution for both the type of data, and the comparison of these 2. We try to look at it. Here you can see in the table I. This shows that the classified RF model, NLSM referred non-slide points, which is giving highest AUC, that is the highest accuracy, so which can be considered for the development of LSM model for the Chamoli districts. So finally, what we did is we trained the RFM model, and it is used to develop the slope unit based landslide susceptibility map for the Chamoli district, and this is of the first kind in the country. And the second step, what we have done is we want to look at the rainfall thresholds of the particular study region, that is here Chamoli district. So what we have done is the thresholds are also very important because of the regional and the local events, in developing the early warning system. So we applied all the empirical approaches and all the threshold methods starting from empirical, probabilistic, and the advanced algorithm models for Chamoli. And the hourly intensity of these rainfall events, which are associated with the occurrence of the landslides, were considered, calculated, and then plotted against the duration. You can see here, we try to see, because similar to earthquake, rainfall is also highly dynamic parameter. It is not just only rainfall intensity. You also has to take, rainfall duration, antecedent rainfall, and other parameters of rainfall as well when you, trying to understand. So that's why, like, probabilistic methods, we applied both one-dimensional, two-dimensional bias approach. And then in Sigma model, which is a highly advanced algorithm model, actually we modified the Sigma model because we are working with a collaborator who developed this, and we tried to build a multiple alert levels. So it's like a trial and error kind of model. So where we try to, make it tailored that to this particular region, considering its site-specific parameters. So here, like, this is a gridded rainfall data we have considered from 2007 to 22, because you need to have this rainfall, at least, the rain gauge should be minimum, with some range. Like here, our grid range was around 1.5 degree. So what we have done is, like, for threshold derivation, 116 incidents were considered. And each grid data is obtained from the inverse weighted average method for a rainfall data, which is around the distance of, as I said, like 1.5 degrees. And then throughout the time period of this 2007 to 2022, we had considered like this 116 events, and there were totally 74,000 something rainfall events were recorded. And all these number of events, that is rainfall events, that after, considering only landslide triggering gits. So finally we got something around 15,600 something. So then we derived the empirical thresholds, and the intensity duration thresholds were obtained using simple power law and standard approach, and the event duration thresholds were derived using CTRLT algorithm. So almost all the papers have been published. Interested students, like or researchers, they can go through. You can find the papers in my Google Scholar. With a probability of exceedance of 5%, a rainfall of 10 mm for a duration of around 10 hours can trigger a landslide in this Chamoli district. So this is one of the outcome from this analysis. And the empirical thresholds, they compare an input value with a defined thresholds, and it have a single output, like a triggering or non-triggering. So it gives you, like, whether the landslide can be triggered with this rainfall parameters or not. In CTRLT, which is as I said, like, it's algorithm-based approach, it extracts the rainfall event automatically from the daily precipitation data which we give it as an input. And then hourly precipitation data and landslide data along with the geographical locations, that is the coordinates, date of occurrence of the landslides, rain gauge location, and also setting our climatic parameters of rainfall events, they are required as input to obtain the thresholds. That means, like, giving a lot of site-specific parameters. In our case, we also try to include vegetation parameters also. So there are two main logical components in the algorithm, which is like automatic reconstruction of the rainfall occurrence is done initially. And the second one, it determines which rainfall occurrences results in landslides. So then the probabilistic approach. So this is the one-dimensional probabilistic thresholds, like, as I said, like using conditional probability. So this is the results of that. One-dimensional threshold, event duration thresholds were found to have highest AUC. You can see AUC analysis has been done with the ID, ED, and EI. So this is the two-dimensional thresholds we derived using, again, Bayes theorem. So this is the Sigma model. So this is the algorithm-based model threshold approach. So in this one, like 7 grid points are considered as a rain gauge studies in this study region. And the model used standard deviation of a statistical distribution as a key parameter for the analysis, and then defines the thresholds as a function, of this deviation, predicting the potential of rainfall to initiate a particular landslide event in the study region. So it is a little bit, very advanced model, and this is based on this statistical distribution, as I said, and easily we can exportable to other regions also. So the modifications are in accordance with the historical database that we collected for the study region, and then making the sigma compatible for different hydrometeorological, because it's not just only geotechnical parameters which are controlling the landslides. Actually, it's more of hydrology. So landslide hydrology is a major component which we need to understand. So hydrogeological, meteorological settings of that area for which it is originally developed has to be considered, and the precipitation data, especially the daily precipitation data, we added. And then there is a window which moves at every day time steps throughout the rainfall data. So that window that we have to vary from 1 to 365. Then we'll get a cumulative probability distribution as it is shown in this figure. We do the analysis, and these are for the 7 rain gauge locations in particular district. So 3 sigma thresholds were optimized. And you can see from this figure, which is showing the algorithm developed for calibration of this particular model for the sigma region, that is for the Chamoli region. And if the red alert is generated when the rainfall crosses a threshold of 2 sigma, and orange if it is 1.75, and then yellow if it is 1.5. So this is the statistical comparison of all the thresholds, and it shows that sigma model is performed best for the study. With the highest AUC, which is coming around 0.92, and this demonstrated high sensitivity accurately, which is predicting almost 41 landslides out of 44, which happened between 2020 and 2021. So the false alarms were 3. And then we tried to do the soil thickness mapping for the Joshimath. As I said, like we started with the Uttarakhand, then came to the Chamoli, then in Chamoli we just finally converged to Joshimath. So precisely determining the thickness of the soil, that is a overburden, which is a very, very essential parameter in modeling, which is also difficult, when you want to apply to heterogenic large scale areas like this. And current prediction models which we have, they preliminarily concentrate on shallow soil thickness, and they are also lack comprehensive spatial coverage. So but here in this study, this limitation, by presenting the results of this soil thickness assessment along 3 important roads in the Joshimath. One is like Joshimath Badrinath Road, Joshimath Malari Road, and the third one is Joshimath Pipalkoti Road. The geological map, it identified 5 different formations which are there in this present study. You can see here from the table 5. And using this information as the foundation, the study area was, then divided into 5 distinct units based on the geological formations. So this is the methodology. We adopted 3 different methods. We examine incorporating geological and geomorphological data as input to obtain the soil thickness map. So here you can see here a customized version of the conventional GIST model, which is called geomorphologically indexed soil thickness model. And then we modified this one, enhanced by incorporating Monte Carlo simulations, which is GIST MCS model. And then third one is like we try to put random forest algorithm, we integrate that into the conventional GIST model, which is GIST RF model. So in these, we try to do the analysis in both 3 models, and then we try to compare the results. So with respect to soil thickness map and factor of safety and pore water pressure. So these are some of the factors. Which is in GIST model, we have a factor C, which addresses the influence of the surface curvature on the soil thickness. And then DM was used in the study. For DM, we have done some drone surveys in the Joshimath region. Then GIST model, which we incorporated with other factors like factor P to take into consideration the relative position of the points inside the hill slope profile. So then this integrated with the factor P to determine and understand what is the connection between the different index points and distribution the soil within the hill slope. So after doing the analysis using 3 different approaches, of course, this is another details about what factor C is in this GIST model. This is the third factor, and which is take account into the influence of the inclination of the slope, which is also important, significant role in erosion phenomena, especially on loss of soil, because somewhere erosion and will lead to somewhere deposition also. And this investigation, the adjustments were made into the factor C also, which formulation for the better accommodate steep terrain character. On the right side is the shear wave based on the shear wave velocity values, which was in line with our soil thickness map also. So validation again with the geophysical testing. So from these things, like we performed LSM by incorporating Monte Carlo simulation, because that was the one which was giving good results from the previous validation simulations. And then what we did is like we also applied TRIGRS model for this particular one road we selected, so which is like Joshimath Badrinath road. So this is the details of the road which we started doing. And then in TRIGRS model, so we'll get like we can get three things, like one is factor of safety, one is like pore water pressure, and then we also get the failure depth as the output. And here the spatial variations of the geotechnical parameters we model using Monte Carlo simulations, and the soil thickness we derive from the previous study which I just explained, that is the conventional GIST model incorporated with the Monte Carlo simulation. This is the input parameters for modeling. So for different parameters, like including hydraulic conductivity, flow direction, slope angle, etc. So this is the soil thickness map which we obtained, incorporate GIST and MCS. You can see here the thickness is varying, from 0 to almost like 22 meters or something, which is also, validated through shear wave velocity profile. So this is the results. Final results show that major portion of this region is highly vulnerable to the landslide failures. And here we got an accuracy of around 93%. So the final step was like, with this, we had an experience of developing a regional scale forecasting for Western Ghats, especially for Idukki and Wayanad, and also for the local scale forecast early warning system, which we developed for Kalimpong, again supported from DST. This is more complex framework for Uttarakhand, because here we have to consider several parameters, and also we have to consider both regional and local scale forecasts. So this is actually the operational early warning system which we developed. In the case of Uttarakhand, because as I said, it is more complex because the triggering factors are rainfall, and in between, winters, they also have a snowfall. So we also installed a weather station in the starting of, because we don't have the, we want the seismic data. And what we did is like, we we also did PSH analysis, which I didn't present over here. And then based on that, the high seismic zones have been identified, and seismically induced landslide zones were demarcated. Then we evaluated the distribution of rainfall based on the PSHA details or the map. So based on this observation, finally we selected Joshimath for real-time field monitoring, which installed a very dense network of instrumentation has been made in the Lambaghat village. And our previous studies on Kalimpong, there we had only used tilt sensors, because the failure or the type of slides that they had is like very shallow type of landslides, and that's why we instrumented tilt sensors and moisture meters along with the weather station. But here we had a very dense network of boreholes, both in the sensors, both in below the ground, around 15 meters below the ground, and also surface sensors. So this is the selection of the road details. And even in this one, in the Lambaghat village also, in this particular road, we were not sure like where to put our instrumentation, because there are several factors including safety, electricity, all these things plays a major role in selection of the site, because maintenance also, we need to have a volunteer who can go and do the maintenance just before the starting of the monsoon. So because it's not easy for us to travel like twice a year. And also electricity point, we are paying, I mean, we have an electricity connection on my name in this particular site. Actually, it was not easy to get an electricity connection also. So a lot of challenges are there in doing such kind of, real-time monitoring. Anyway, so in the starting, what we did is like, we have done extensive field visit for the selection of the site, taking these factors in mind. And then finally, we selected the site 6, which is a Waknaghat landslide zone. And I should thank BRO who are supporting us, like who supported us in doing this instrumentation process as well. Because finding a contractor to make a bore log there is also not so easy, because no contractor comes or investigation agency is ready to make the bore logs and something like that. This is the geotechnical, bore log data. So we have done at all the 6 sites. In addition to other qualitative factors, we also consider some quantitative factors in selection of the site. So this is the Waknaghat landslide zone, which is like one of the on the NH58. This particular site is on NH58, which is a very critical route, which is going towards the Badrinath. This particular road is very crucial not only for pilgrimage and also for the army related operations. So you can see here from this figure where we instrumented our sensors. So these sensors have been strategically installed in the beginning of the June, sometime in 2021. And because you can see here several sensors have been instrumented, like we had accelerometers, piezometers, volumetric water content, inclinometers, strain gauges. We had a weather station. We also put a high camera where, because this road had several heavy vehicles moving, so we want to consider that ambient vibrations also, because we had a microseismic monitoring system instrumented in this particular slope. So what we want is, like, we want to remove that ambient noise. So that's why we put a camera as well. Then this is the drone survey details. So it was carried out in high resolution. Aerial images of this landslide area was captured, and which is equipped with a high resolution camera. And these images were used to create the 3D DM of this particular study landslide slope or landslide zone. And we had to identify areas of damage and the potential risk. So this, you can see the images. They were also used to create the topographic maps of this particular slope, which we also useful in identifying the drainage pattern. So which is very, very crucial. And what we observed is, like, at some points we found out some potential water accumulation points also. This survey we conducted over a period of almost like a week, and the data that what we collected, we used GIS software to analyze, and this survey identified several potential risks for further landslides, including areas where there were cracks in the soil, and also there, as I said, like, potential water accumulation on the slope. So this is a monitoring site, Shimla. So automatic weather station installed at this location. Every 10 minutes we are getting the data. You can see on the right hand how we are getting the data. So we developed our own website. Of course, students at IITR developed this. So we are like, it is I can say that it is an indigenous monitoring system and early warning system, and the data from each sensor we are getting through VSAT to our website, to our server at IITR every 10 minutes. And if the threshold crosses, so you can see here, when the threshold crosses, then warning can be generated. So the interface of the website you can see on the top. So this is a conceptual framework for slope scale early warning generation through hydrological modeling and the slope stability analysis. So what we did is, like, we had 4 stages. One is monitoring, then modeling, forecasting, and the warning. So in monitoring data, we had, like, we have considered hydrological parameters ranging from PWP profile to soil water content data, and then we also added the meteorological data, especially precipitation, air temperature, wind speed, and relative density. Then, like, the data sets, they act as an input for hydrological modeling with the geotechnical parameters, because we had done the boreholes, and then we collected those samples and tested in the lab for validation and of course for calibration purposes. So the calibration process, that refines the hydraulic conditions to closely align with the actual or the observed data from the real-time monitoring. And what we did is, like, we tried to incorporate the climate data as one of the boundary condition, specifically termed as water flux. And then validation, like a critical step is modeling, which is we did it involving comparing predicted hydrological data with in situ monitored data, and which facilitating the determination of most accurate simulation that is reflecting the real conditions over a particular time period. So if you say that like 24 hours or something like that, it will do it for the next 24 hours. So what we are trying to do is like in the last 6 months, we are in the process of, monitoring it for validating. And validation, which is a very critical step, in modeling, and that we are right now, like we could generate a warning, within 6 hours, like at least 6 hours, we could find out the threshold and we can generate the warning. So this is some of the data. So you can see here non-calibrated and the calibrated data. So the temporal and regression analysis of the measured and the simulated water content values across various scenarios over 6 months observed period at different depths suggested for the suitable conditions. So I've been monitoring for the last 2 years. So and to understand the significance, what we did of these climatic drivers and the vegetation dynamics, I can say that like everybody has incorporated in the warning system this climatic factors or climatic drivers or the vegetation dynamic parameters also, so that we try to incorporate. This is a conducting comparative analysis between the simulation results and the in situ measurements, so through Taylor diagrams for more clarity. And this is the temporal performance evaluation over different time frames. Okay, so which identifies like 12-month simulation was giving us good results. So these are some of the results. We tried to validate that like the objective was to forecast the time period basically when the slope is unstable or prone to manifest. Then if it is exceeds the thresholds, detecting some factor of safety which is less than 1.5, then that warning can be generated or activated. And in this process, random forest machine learning model demonstrate impressive accuracy. So as I said, like it was giving around 92%. So that's all. Thank you so much. So if you have any queries, I'll be happy to answer.
Thank you, ma'am. Thank you very much for that insightful lecture over the landslide and landslide system warnings as well. So with your kind permission, can we please go to the question answer session?
Did someone raise the hand? Dr. Rahul, please.
Yeah. Dr. Rahul, please unmute yourself and ask the question, please. All right. Can we go to Dr. Yashpal Sharda? Can you please ask your question?
Yeah, Dr. Nilima, thanks for a wonderful lecture. So I want to know one thing. How much weightage you have given to human factor? Because human factor is very important in causing the landslides.
Sir, that was not considered because there is no quantitative parameter to consider that in my modeling. I do understand cut slopes, etc. But the monitoring where we did this is like that's a virgin slope. It was very difficult to find a slope, without any mitigation measures in this particular road because many stretches have been, mitigation measures have been taken care. So mostly done by BRO. So this particular slope was like we try to because you need to know the ground signature. So that's why we spend a lot of time in selecting the site as well. So it was a virgin slope, trying to capture the real movement of the ground.
But because I am suggesting this because human factor is a very important. Most of the majority of slides occur due to human interference on the slope.
Yeah, exactly. But there is no quantitative parameter to consider that for taking some weightage or whatever reason. That's why we didn't take it.
You have carried out landslide hazard zonation also in this area.
No, so except we did it. rainfall for and real-time monitoring. That's all.
Okay. Thank you.
Yeah, sure. Thank you.
All right. Meanwhile, we have also shared the feedback link for today. So the contestants are please kindly requested to go to the feedback link. Moreover, there is important announcement that we'll be having international conference on civil materials and environment for sustainability coming on in the 4th and 5th
Somebody has
of
put
October.
something in the chat box.
Yeah. I've given the link in the chat box as well. Please go through the link. Moreover, if there are any other questions, please you can kindly unmute yourself and ask the question. There were certain raised hands. Can you please unmute yourself and ask the question? All right. I'll go to the chat box and read the
I think
questions which are
someone has
posted
put
here.
something in the chat box.
Yeah.
I could
So-
not open my chat box.
Yeah. So first question is from Dr. Saurav. Please tell about the use of sensors for landslide prediction and what is their accuracy?
See, every slide is very different. You cannot ask. This is a very generic question. So I said, like in Kalimpong, like we put tilt sensors because that was very shallow landslides. But here it is not a shallow landslide. So we put it at different sensors. You have to design that. So many times people think that I develop a warning system and I can put it. No, it is not possible. So for developing every landslide warning system, you need to do the analysis, or you have to do all the work considering the site specific parameters, type of the landslides, thickness, drainage, hydrological characteristics. There are several parameters are there. And coming to the sensors, if you go to the market, you get sensors from different range. Okay, so and in our study, like I started working on this monitoring for last started in 2016. What we did is like with my experience, what we did is like we bought sensors of very good quality, but integrating the system and the website, everything we developed in house. Okay, because if you go with a buying it also the entire system costed us for 40 lakhs, but if you go to complete system to procure, it costs highly uneconomical also. So what we did, we have to where to sense, what to sense, everything you have to do the analysis before, and then only we can instrument it. So don't think that instrumentation is very easy. It's just putting some sensor, it gives you some parameter. No, but you should know what you want it and why you want it. Where to put a sensor is something very, very crucial for that. What we have done, bore logs, we have done geophysical tests, MSW, VRT, we have done several, detailed study, then only we could put it. So question is very generic, so you have to study in detail.
Okay, ma'am. Additionally, I wanted to ask, is there some particular amount of ground displacement that you have decided for like raising a alarm warning or something?
No. So it's not about displacement. See, in forecasting, what happens is like we are trying to incorporate which parameter of like what is the amount of rainfall, how long it will cost in this particular site is sufficient enough to fail. Okay, so that is what we are trying to do. Similarly, we are putting earthquake also. What is the PGA? Right, PGA, earthquake magnitude is not the parameter, right? You need to get the site specific. That part I didn't put it up, but we have a paper in Journal of Asian Earth Sciences. People interested can go and check. So what we need is like a PGA or air intensity. We developed it, and at different pixels, like I know which is that parameter of the earthquake which can trigger a slide in this particular site. Okay, so those two things we try to incorporate. So what you are asking is like the subsidence value which can trigger. So see, subsidence is an effect, but what I'm trying to do is like forecasting.
Right. People always argue on these things like sensors and what is their accuracy. Many a times we also get some false warnings.
Very accurate. See, let me tell you, we do have in the market very good accurate sensors also. It's not like we don't have it, but only thing is they're costly. Okay. And so if you buy a sensor from some company and another sensor from another company, you need to have different data loggers. Okay. But in our case, we try to integrate that. So that is actually good part that has been done.
Okay, ma'am. Thank you. Let's move on to another question from Sneha Gupta. Why is there a lack of research on landslide and liquefaction analysis for the Sikkim zone?
No, it is there. It is there.
It is there. I think
I
there
think
are some.
yeah, there is there.
Yeah. Another question from Kaushal Kumar ji. Can we accommodate Monte Carlo simulation for landslide in different regions?
Of course, we did that, right? We did, yes.
Okay. Next question is from Sufyan Mirza. Could you please share some examples of successful landslide mitigation projects and their outcomes?
There are many actually. McAfee has done, Terami has done. So there are many such projects that the BRO has done several successful mitigation measures. So yeah, Tindaria slide is, I feel like it's very, good case study.
Right. Another question is from Badawat Naveen. Madam, for the development of rainfall threshold, minimum landslide inventory should be considered.
Yeah, actually, this is a very, very tricky thing. Sometimes people develop a threshold with 40 events also. More data is always good, but more than that number, what I see is like, you have to divide that region into grids. Okay, the location of the rain gauge is something very important. When we started, I'll just give you an example, you can understand better. So in Kalimpong, what happened is like when we started the work in 2016 for developing the rainfall thresholds, so the rain gauge was in Teesta 9th mile, okay, which is very far from my study area. So, even now, like within few kilometers, there is a change in the rainfall pattern nowadays, like whatever climate changes, etc., etc. But in such kind of things, at least like, you should have, you have to divide that based upon the number of rain gauge locations. So good number of network is always better. So in our case, what happened is like we first instrumented weather station, and then we started getting our data in our study region. It is a small town. Kalimpong is not a very big town, so it's a small town. So then we started generating our own rainfall data, and then we started doing the thresholds. Yeah, less data also people start. For smaller areas it is okay, but for larger areas no. In Western Ghats, you can see our papers on rainfall thresholds. Especially it was good that we had several dam authorities, and but getting data is not so easy from a few organizations. But another very important thing is like if you had data from too many rain gauges of different things, we use a digital rain gauge. So but there are quality wise also you had different kinds of data, so all these things is
Right. Next question is from Dr. Saurav Rawat. In your opinion, ma'am, what are the most critical parameters should one consider if an early detection system for landslide is to be fabricated?
in Euro.
No. What are the most critical parameters should one consider if an early detection system for landslide is to be fabricated?
I didn't understand what is fabricated. I consider that you want to say as a dollar. Okay.
Yeah.
Yes, I explained several parameters. Landslide is a very complex phenomena. It is not just only your geological or geotechnical data. It is more of hydrology. Okay. Hydrology or landslide hydrology is the most crucial parameter which you need to consider. You need seismic data, and see, as I explained in this particular study or case study, so we had taken seismic parameters like of course because of the time constraint I didn't go through that. We have taken PSHA analysis has been done, and then PGA and areas intensity maps have been, all of that factors. We have taken rainfall, all rainfall parameters we have considered. As I said, rainfall is a dynamic parameter like earthquake. So intensity, antecedent rainfall, duration, all parameters of rainfall we have done, and then probabilistic analysis has been done, and then geological formation details which I showed in the slides also done, right? And we have taken the soil details, right? Geotechnical bore logs have been made and then tested in the lab. Geophysical data has been taken. So you have to take almost all the parameters for developing the early warning system. It's not just taking only rainfall and then creating a threshold. You may land up with a false alarm. See, warning system building is a kind of trust building, right? So, and we are not authority to give or issue a warning, right? It is actually some administration, right? Either panchayat level or district level administration has to give the warning. I can't give a warning. I only can develop, and finally the state disaster management authority. So who are the administration part? They have to issue the warning, right? So in this perspective, when you develop that, you have to make a warning system with the least or zero false alarms. If you generate false alarms, even 1-2 false alarms, also people lost us, and there's no point of having such warning system. So warning system is something very, very crucial. So we've been working closely with the state disaster management authority so that it can be implemented or used by that. And for Kerala, the interesting part is like we develop this warning system at panchayat level. Okay, so that the panchayat administration can issue the warning. So
Right.
yes.
Moreover, I have a query that how you are able to tackle like the hydrological data. Like in nowadays, the rainfall pattern is changing too much because of the global warming effects and all. So can the past data be relied that much?
Yeah, past data you cannot even completely discard also, because then you land up with zero, right? You have to take that. Along with that, we had our own, rain gauge, and then we started working like that.
All right.
You have to take that. It's not like you can discard. If you discard it, you will land up with zero.
Yeah. So next
The
question
pattern is changing. Knows that the rainfall pattern is being highly varied, right?
Yeah, we witnessed that thing in Himachal region last year. We had an intense rainfall.
I witnessed here in Indore also.
Okay. So next question is from Deepthi Hazari. Okay, it's the lot of praises for your lecture. Thank you. And next question is from Nidhi. Under such areas under consideration for studies of landslides, there may be occurrences of tunnels in some of the areas as well. So how to study the behavior in such cases and how to ensure safety in such cases?
Our warning system is at the local and the regional scale. Okay, so within the reach, we didn't had any major infrastructure projects, maybe tunnel, bridge, or like hydropower projects. So there is a scale. Okay, for warning systems, there will be a scale. Right? So as I said in the starting of my slide, we were developing that local and the regional scale.
All right. So next question is from Naveen. How we can relate soil erosion and geotechnical parameters for LSM?
Yes, we have done the GTCS model integrated with Monte Carlo simulations. Okay, so we could do that. There are some modeling techniques. So you could do that. Erosion deposition models are there. Especially for debris, it is very predominant. What happens in debris? Okay, there's a huge amount of erosion and deposition. Right? So based upon the velocity, entrainment characteristics, etc. So yes, but this kind of slides, I think erosion was not such a big issue. So that can be incorporated.
Next question is from Mr. Sher Bahadur Singh Parihar. Actually, he also asked the question yesterday to our previous speaker. Well, ma'am, thanks for the excellent deliberaties. Do you feel that the government of Uttarakhand will consider outcome of such researches, slides in forming legislation to protect the people for such landslide hazards?
So I'm in touch with USDMA. So yeah, I think they may take time to adopt it, but it's not like they don't. The government is also looking forward, and that's why they fund also.
Okay.
It's only problem of integration.
Okay, so next question is from Suraj Raj. Can we use DFOS, distributed fiber optic sensors, for landslide warning systems?
It's too expensive.
Yeah, I think the mass scale which you are using, that will be very expensive.
See, we are doing one site for mining company. Okay, for mine dump slope, it's too expensive.
All right. Another question is from Sandeep Ji. He's asking if we have to consider for soil sample collection at sites for landslide prediction based on lab testing.
We also did, no? We did them bore logs. At the time of selection of the site itself, we made this geotechnical investigations. At almost all the 6 sites, we initially, decided. So we have done the bore log data up to 30 meters. We made it and then collected samples. We, tested in our lab to understand its properties. Yes, we have done.
All right. I think we are done with the questions. There are a lot of praises for your lecture, ma'am.
So thank you so much. Thanks to Neeraj for inviting me for this particular event. I can drop my email ID. Otherwise, you can find it out. So if you still have anything, you can send an email, or my WhatsApp number is also on my page. You can WhatsApp me as well. So yeah.
Yeah.
Infiltration rate.
People have raised hands. If anyone still want to ask any question, you can just unmute yourself and ask the question, please.
Good afternoon, ma'am. Dr. Sugandha Singh here. Very nice lecture. Unfortunately, I did miss a part of it where you discussed the early warning system and threshold parameters. I'm sorry for that, but I was very interested in understanding how you tried to do the earthquake, combine the earthquake with landslide hazard. You said the parameter that you selected was PGA. So did you do the site-specific hazard studies with the PGA and area intensity and all of that? And
Yes.
how did you model, maybe if you tried to do it, how did you model the attenuation and all of that in the model?
Yeah. See, when we started the project, I mentioned in the starting of my lecture, so I think that's what you missed it. So we started with Uttarakhand, right? Then we converged to the monitoring. So our goal at the end was to develop the local scale early warning system, okay, which we can, build to regional scale as well. So local scale was at the Lambaghat. So Lambaghat didn't, came in the starting. So what happened was, like, we started with the Uttarakhand state, and for entire Uttarakhand state, we have done the PSH analysis based on that, and then we have done the LSM for the Chamoli district, because from that we understood that Chamoli is the most vulnerable. Okay, and then we came to district level, right? Chamoli district, and then again we did the thresholds for the entire Chamoli, right? And then we converged. So it's not like, in the starting of the discussions, we were told that you take some site in Uttarakhand and develop the warning system. This is what the statement we had, or we gave it, because my proposal was not on Uttarakhand when I first proposed. Actually, it was in Shimla, near Shimla.
Right.
So, but reviewers asked me to go to Uttarakhand. Okay, so I was fine, because that is also more complex thing. So that's how it started. So we converged it to Lambaghat.
Okay. So, I mean, that makes sense also. I think Uttarakhand does have a much denser seismic network as well, if you consider earthquake.
Exactly.
But because I have done little bit of work in attenuation parameters, specifically site-specific kappa. So I was interested if you did incorporate or modeled kappa for the sites in Uttarakhand as well.
Yeah, attenuation we don't need to, when we already had the surface PGA, right? Okay. It has been considered.
Okay. No, the
attenuation is already considered.
Attenuation is considered in the characteristics. Maybe if you have a PGA, is the frequency parameter of any importance when we are considering an insight then? Because attenuation basically controls the frequency band that we see.
No. We We try to bring the PGA, the surface level, including the topography. Okay, that value we have done.
Okay.
I think that is sufficient, because in a hilly terrain, attenuation is not easy to do that, because concave, convex,
exactly.
A lot of complex phenomena. Considering topography in a hilly, it's easier in a flat because I did attenuation things, for Delhi region sometime in 2006. So plain terrains it is easy, but topography it's like hilly terrains or like this kind of varied topographies. It's not easy because you need to do a very detailed modeling.
Right.
Three-dimensional.
I also had one maybe probabilistic calculation front. You've used Monte Carlo simulation. From little experience I have with the method, it is also depends on the number of cases we have or number of data we have. So the higher the data, the better accuracy is. So was there a study that you did?
74,000 points or something.
Okay.
We had left it.
Okay. Thank you, Anil.
Now I get more emails asking for data rather than asking for papers.
No, I think I would be very interested in reading your paper, specifically on earthquake side. But Monte Carlo simulation, I faced problems where the curve changes based on the number of data points we have. Thank you.
Okay, ma'am, meanwhile, we have another question coming in. That infiltration rate plays an important role in landslides. Can these parameters be counted?
Yes. Very good question, actually. This infiltration parameters have been considered in hydrological studies. So in Sigma model, it will be considered. It's there. The rate of infiltration has been considered. It is very important. Otherwise, there is no point of considering the landslide hydrological aspects.
Right. So shall we assume?
Actually, very complex geohazard, I can say. Why? Because if you look at from the geological perspective, there are different parameters, geotechnical, hydrological. So there's all factors can add, things for the landslides, right? So it's a complex behavior and interesting. So if I see from the geotechnical perspective, if I see only C5 values, that doesn't help. Okay, if someone see from the geological perspective, okay, formation details or the fault details or some kind of rock mass parameters, etc., that doesn't help. So if someone look at only hydrological parameters, no, that doesn't help. So you have to integrate all the factors.
Right. So shall we assume that we are done with the questions, or any other questions are remaining? Okay, ma'am, I think we are done with the questions. So I thank you very much on the behalf of entire IGS Shimla chapter and also Civil Engineering Department JUIT for considering our request in such a short period of time and in a very busy schedule of yours to come here and deliver a lecture. Thank you, ma'am. Thank you very much for joining us.
Thank you so much, Neeraj, and all the very best for future events. Thank you so much for your entire team and all the participants also for active participation. So I enjoyed interacting. Thanks again.
Thank you, ma'am. Thank you very much. So we'll be meeting again tomorrow 11 a.m. For a lecture by Dr. Rohan. He's expert in finite element analysis. So please join us tomorrow at 11 a.m. in the morning. Thank you.